Hi all, this is lectures video series. This is series video number 1. This video comprises of introduction to dependable systems. So this is a subject called 23 AMT 304 software engineering. On this topic we are going to see about dependable system in the subject called software engineering. Okay. Before going to this slide, we are going to see what is the recap of the session. The recap session is before class we seen about what is going to be a software system. The software system is a process-driven system in which we are going to have a failures impact such as failures is from the user, business, and society, and their exhibit is called transition. The transition, that is, today we focus on building software where we can able to increase the value called trust. So in this video we are going to in this class we are going to think, pair, share possibilities. So first of all we are going to have a question sessions. What is why dependability matters, and as for the question session will be what happens if Google Maps fail for 10 minutes. That is, when a Google Map failed for 10 minutes, they cannot able to find a location. The Google Map also failed, so we cannot able to go to the perfect location. Next, the session objective. The session objective at the end we are going to know what is meant by dependable system. We are going to explain the core attributes such as reliability, attendability, availability, and safety. Next, we are going to identify real world applications, and we are going to apply design thinking to dependability, and relate concept of future AI critical system. That is, in this session we are going to see about a term called dependable system. That is dependable system. We are going to define dependable system. Next, we are going to see about core attributes such as reliability, availability, and safety. Next, we are going to see identify for real world application, and from identifying we are going to apply design thinking to dependability and related code to future AI and critical systems. Okay. Next slide. So we are going to see the problem statement. In this problem statement we are going to set a real-time problem statement. That is, Ravi is a software engineer in hospital in IT system where he works on patient monitoring system, patient monitoring software, and he faces pressure to release update of passwords. Any failure it talks to risk to the patient lives. So this from the Ravi point of view, you are going to have a problem statement. The problem statement is nothing but how can we ensure the system correctness and real world failures. That is, we are going to have a system. We are going to check whether the system that is correctness under the real world failure. So for this we are going to say as we are going to have empathize. In this empathize, we are going to understand the Ravi challenges. That's nothing but high reliable. That is, understanding Ravi challenges. We are going to have empathize. Empathize consisting of high reliability of expectation, regulationary constraints, and continuous of monetary needs. So this is what empathize we are going to have. So from this we have high reliability expectations, regulatory constraints, and continuous monitoring needs. Okay. From this, what we are going to define is nothing but we are going to have a core problem. The core problem is nothing but we are going to, in case the software is failure in critical system, what we are going to do. That is, if the software fails in critical system, which can lead to catastrophic outcomes. So we are going to design outcome system zero tolerance of unsafe behavior. So the core problem identified, the defense system consisting of a core problem identification where the software failure in critical system can cause to lead to catastrophic outcomes. So we are going to have a design constraint. In design constraint is a zero tolerance for unsafe behavior. Okay, next we are going to ideate. The idea is we are going to find numerous number of solutions. That is possible solutions. Possible solutions nothing but we are going to have redundant components. We have fault tolerant design, continuous testing and monitoring system, and formal verification system. That is, the possible system. First you have to have reliable redundant components. Redundant components, and you are going to have numerous number of saved already available systems. Next you are going to have fault tolerant design. That is, the design doesn't have maintenance of fault tolerance. Next we are going to have continuous testing and monitoring of the system. We have a continuous testing and monitoring of the system is there. So we have formal verification. This is what this idea comes from the defend part. The defend part is a core problem where software fails in critical system, issues catastrophic outcomes, and the decision consider zero tolerance of unsafe failures. So we are going to have a term called ideate part. In ideate part we have possible solution. The possible solution compromises of redundant components, fault tolerant designs, continuous testing and monitoring, and formal verification system. Thank you. Next step we will going to see about temple product. Thank you for watching this video. Thank you.